Hear this? Don't want that yet, right? Zoom recording. All right. So this is our first class. This is Tuesday, week 1. Now, a couple of things. First, chapter 1 is super boring, and I promise it will not always be this boring. In fact, it gets super interesting. And I'm hoping I'm not just saying that because I love math and I love what I teach. It does as we move on, it gets super interesting and very useful. The chapter 1, stats is kind of like its whole new language. So chapter 1 is a ton of vocabulary. So it is a little bit dry, and I'm sorry about that ahead of time. I'm sorry for the dry content ahead of time. My name's Melissa Kleiss. Feel free to call me Melissa. We're all a bunch of adults here. I think of us as just a bunch of people hanging out, and I just happen to have information you need because it feels weird to me when adults call me Miss Kleiss or whatever, but it's okay if you want to. If you're more comfortable with that, go for it. But feel free to just call me Melissa. That's my name, and I will answer to it. Um, so I had something else. Our class is pretty small this term, but I love that because it means I can grade things quicker. It's a little bit more intimate setting, and I think that it's actually going to go over really well having a little bit smaller class. I do front load the class and move a little bit faster in the beginning, and the workload is going to be a little bit heavier in the beginning of the term, and then it'll taper off just a little bit because we do have a final project. About halfway through the term, I will be giving you your final project. And because I want you to spend more time on your final project, I will back off of the homework load just a little bit. So the beginning of the term is a little more homework heavy and a little bit more, I'm going to be getting more chapters in more quickly. And then at the end of the term, I ease up a little bit so that you have time to work on your project. And plus, I know that some of your other classes will ramp up at the end and get more heavy workload at the end. So mine is front loaded a little bit. So if it feels like it's a ton of work right now, which it is, if it feels like that, just know that you have some relief coming. This class is kind of heavy anyway, heavy workload anyway. So when we take 8 weeks of a class or 11 weeks of a class, squish it into 8 weeks, it becomes a lot. And I'm apologizing ahead of time, but I will do whatever I can to help you be successful. You do have 5 late passes. So what a late pass does for you is it extends the due date 48 hours from the original due date. You have 5 of them that you can use in the term. And you can't use them on labs and you can't use them on a test, but you can use them on everything else. And well, not the discussion forum, but the discussion forum is 5% of your grade. It takes you 2 minutes. So I hope you can just stay on top of that. So I use them sparingly. Don't use all 5 of them in the first 2 weeks of class and then don't have any for the rest of it. Save a couple for in case there's some sort of an emergency. So you do have 5 late passes. So I just wanted to make you aware that that is a thing. And those can be accessed when you click on the assignment in My Open Math. It'll give you the option to use a late pass. And if you struggle with that at all, just send me a message and I will help you out there. As I said in the welcome video, I hope everybody watched that. I try to check in a couple of times a day, make sure that I am available if you have questions or need anything. The weekends, I spend a lot of time with my grandkids, so I'm not quite as available. I will try to check in at least once a day, definitely at least once in the weekend, and I send an email out every Sunday morning telling you what the new week is going to be have happening, what is on the I don't know what is happening the next week. It's summer, it's hot, you know. So, anyway, I'm going to get going. We're going to start with our chapter 1. So, chapter 1, or this is our objectives today. Chapter 1 is all of the vocabulary. Then, chapter 2 is we're going to start taking our data and we're going to start organizing it. We're going to look at tables, we're going to look at bar graphs, we're going to look at pie charts. It's going to be stuff that you're familiar with, but it might have a little bit different vocabulary than you're familiar with. So that is going to happen today. And we will at the end of today's lesson, I'll talk about what data you're going to need for the lab that we're doing on Thursday. You will not need your fancy calculator today. You may need it on Thursday, but you will not need it today. No fancy calculator today. So the math today is super, super simple. Basic cell phone calculator will work for that. All right. So let's get going. Okay, starting off with some super basic vocabulary. So statistics itself, um, it's just a science. It is treated like a science. We use the scientific method, kind of tweak it just a little bit, but we do use a version of the scientific method with statistics. But instead of being like a biology or a chemistry or a physics, it is the science of studying data, of collecting it, organizing it, summarizing it, analyzing it, and all of that stuff in order to draw conclusions and to make predictions. You've seen so much of it with the recent election cycle. It is, statistics are super, super important in all of that. The information that we're using, it's called data or data. I don't know which one is correct. I use both of them interchangeably, sometimes both of them in the same sentence. I will sometimes say data in the beginning of the sentence and then data at the end. You will hear both. The weirdest thing about data is that it is plural, and it kind of drives me crazy that it is a plural word. It is, so you say data are, but it kind of annoys me, so I will not frequently say data are, but I might. So the data that we have, it is the piece of information that we're using to draw our conclusion. It could be numerical, it could be like height or weight or something like that. Could be something non-numerical like gender or like color or something like that that describes a characteristic. It could be either one of those things. So our goal in this class is to use the data to offset any anecdotal claims. We use it to prove a point. We're determining whether it's being misused. We're doing it to make some predictions. And most of looking in the forum so far, every career I've seen so far in the forum could use the information learned in this class to analyze some data and to make it more meaningful. All right. So, few important pieces of vocabulary. So this is something you will be asked in the homework and maybe on the test. I haven't decided yet, but you will need to know this. I'm going to put a star on it. I'm going to try to be really clear when there's something that you're going to need to know for the test. I'm going to try to be clear. I will also try to tell you when it's not something you're going to need to give back to me. So this you will. So a population is the entire group to be studied. So if I'm studying students at RCC, like in our example, all of the students of RCC would be my population. The entire population of Oregon would be my population. If I'm looking at all of Josephine County, could be my population. So if we're presenting a study of RCC students to see if there's a correlation between how much time they study and their grade, that population would be RCC students. This does not mean we're going to talk to all of them. It just means that's what we're studying. The sample is the people that we're going to talk to. It is a subset of the population. So in the example above, if I took 50 RCC students and I asked them about their study hours and their grades, those 50 students would be our sample. And whatever information I gained from them, I would apply it to all of the RCC students. So the sample is the few that I pulled out to talk to or to question or to study. Those few that I pulled out, that's my sample. The population is everybody I'm studying. An individual would be one of the RCC students. So it would be an individual. And now an individual doesn't necessarily have to be a person. So if I'm studying eminent colors of M&Ms, one M&M would be an individual. So an individual is just one piece of data. All right, questions so far? Are we good? Okay, there we go. Moving on. Okay, so when I am in an in-person class, what I do is I walk around and I give everybody a Post-it note, and then I have them answer this question. You're walking down the street, you notice that a person walking in front of you drops $100. Nobody seems to notice the $100 except for you. You can either keep the money without anyone knowing, or you can return the money to your owner. would you return it to the owner? And I have everybody write yes or no, or return or don't return, or something like that on their post-it. And then I collect them and then I shuffle them. So it's completely anonymous because I don't want to know who did what. And then we'll collect this and we're going to actually analyze it. So I'm going to pretend we have 30 students in our class, which we don't, but I'm going to pretend. And I'm going to pretend that 28 of them said they would return the money. So 28 out of 30 is 93.3%. I'm just going to call it 93% because I don't want to try to fit decimals in there. So 28 out of 30 is 93%. I'm going to move it here. 93, 28 out of 30. So a statistic is a numerical summary of a sample. So if we say that our 30 students is a sample of the RCC college, students as a whole, the whole college of students, so that would be a sample. What I have here is a statistic. Statistics represent a sample. I will be asking you about this in your homework and on the test. I will be asking you this. I have a summary of all of it at the end. A few slides from now, I do have a summary of all of it. So just letting you know. But this word right here is going to become important. Descriptive statistics. So if it just describes the data. So if I'm not drawing any conclusions, so this right here is just my data. This 93% describes my data. So if I describe my results, but I don't draw any kind of conclusions, I don't do any other math with it, I just say, hey, 93% of our class would return the money to the owner. This is just descriptive statistics. I'm just describing what I see. I didn't do anything with it. I didn't apply it to a population. It just is what it is. All right, moving on. So once again, 28 out of 30, 93%. So inferential statistics. So let's say that I'm going to take this information and I'm going to apply it to all of RCC students, the entire population of RCC students. I'm applying my statistics to that. I'm making an inference based on my sample. So I'm going to apply it to everything. So when you do this, though, you need a margin of error and you need a level of confidence. Don't worry, you will get that in chapter 9. Not worried about how I mathed it out right now. I'm just going to say, let's say between 90% and 96%. This is just, I pulled it out of the sky. I did not math it out. I just pulled it out of the sky. We can say that with 95% accuracy, that between 90% and 96% of all RCC students would return the money. So I am taking my statistic and I'm making an inference and applying it to the entire population. So once I actually take that information and apply it to the entire population, that's inferential statistics. I'm applying my sample data to the whole population. So let's move on. All right, this is the kind of summary right here. So statistics are based on a sample, are a numerical summary of a sample. So we also have, that would be this one right here. A sample of 250 students is obtained, and from this sample, we find 86.4% have a job. This is a statistic because it's based on a sample. Now, this right here is a parameter. Parameters represent the population. Think about that parameter starts with a P, represents population. Statistics starts with an S, represents a sample. That's how I remember it. So these right here, you will get questions about, is it a statistic or is it a parameter? You will get questions about that on your homework. I believe you'll get questions about that on the test, whether it's a statistic or a parameter. So statistics, sample, parameter, population. When you're doing your homework, think about, look and see if they took a sample. It may not even say the sample. They may just say, we asked 35 students, yada, yada, yada. So be really careful and pay attention to what is the whole group that they're studying. If they're talking about the whole group they're studying, that's a population. If they're taking a few of them and talking to them, that's a sample. Any questions? Okay. So we take inferential statistics in order to estimate parameters, because our goal in statistics in this class is to make estimates of the population, because it doesn't make sense to poll every single person in the United States or every single student at RCC. It doesn't make sense. So we take samples and we use the information we gain from the samples to make inferences regarding the population. And that's what we do. All right. Moving on, you will not have to go back and tell me the process of statistics. You won't have to do that, but it is important, something important for you to know. So I'm going to tell you about it, but you're not going to have any questions. Ooh, no questions about this. You don't have to write a paper about it, nothing like that. This is just good information. So this is our process. This is kind of our version of the scientific method. The first thing you do is you need to figure out, what is my objective? Now, later on, we're going to talk about hypotheses and all of that. And so that's later. Put that in your pocket. We'll save that for later. We're going to talk about, the first thing we want to do is identify, what is our research objective? What am I trying to study? What question am I trying to answer? There's usually, before we start doing the work, we need to know, what is it I'm looking to find out? What am I looking to answer? I'm trying to figure out, is a certain drug effective? I'm trying to figure out whether lack of sleep causes grades to go down. I mean, there's so many things that we could be studying. So the first thing you need to do is figure out, what am I studying? What's the question I want answered? Next, you want to collect your data. So you need to figure out what it is what kind of data you need in order to answer that question. So step 2, you're going to collect your data. So obviously, you're not going to use the whole population. Later on, so I think it's in chapter 10, might be chapter 9. Chapter 9, yes, chapter 9, sorry. Chapter 9, we're going to talk about how to find out what size sample you need, but right now we're just going to talk about, hey, we're going to collect a sample. We're going to take a sample and we're going to collect our data, and we're going to make sure we collect our data correctly. So many studies do things called convenience samples. That's what this little box right here talks about. They do convenience studies. So if you're standing outside the grocery store asking people, what is your favorite grocery store? Most people are probably going to say that grocery store. Or if you're on Fox News asking if they think President Trump is doing a good job, you're going to get a very different answer than if you have a poll on CNN asking, do you think Donald Trump is doing a good job? There's going to be very different answers there. So those are convenience samples, and they're not there. They have biases. If you're, standing outside of a vet's office asking people if they like pets, you're going to get a different answer than if you go to, I don't even know. I don't know where you would go to find people who don't like pets. I'm sure there's a place that exists, but anyway, you get the idea. So next, after we've collected our data, then we're going to describe our data. This is where you're going to do some math. You're going to do a little bit of math, but this is basically you're organizing it. This is where you're just going to organize it. We want to look at an overview. So kind of like when I said 28 out of 30 of my students would return the money. That's 93%. This is the describing your data. I haven't actually done a lot of analysis on it yet. I'm just describing what I've seen. I've organized it a little bit, maybe put it in a table, maybe figured out what percent of people said what. That's all I'm doing in number 3. We're just kind of organizing it. So number 4, this is when you're going to apply your techniques. This is where you're going to apply your methods. You're going to be learning a lot of different techniques throughout this term. And this is the point where you're going to use them. You're going to do some math on them. And then once you do the math on them, then you're going to apply it to the entire population. You're going to say, all right, so I say between 90 and 96% of all RCC students would return the money if they saw it. This is where I say that 95% sure that 93, between 90 and 96%. This is where you do that. That's basically your conclusion, sorry. So that's what that is. That's your conclusion. Any questions on this process? Feeling groovy so far? I know this is a lot, and I know I'm talking fast, and I'm sorry about that. If you need me to slow down, just tell me. Okay, here's an example so I can kind of break it down and you can see the different pieces. And oh, I don't care either way, whether you have the video on or I can't see it on my screen in front of me, so it's fine either way. It's whatever you're most comfortable with. Just the fact that you're responding in the chat and giving me thumbs up occasionally lets me know you're still there. So if you're more comfortable, it's fine. All right. Thank you for that. That was really sweet. So I'm probably going to eventually change this problem because, well, for one thing, saying the word batterer is hard, saying it over and over again. But this is kind of a sensitive subject, so eventually I'll probably change this one. So many studies evaluate batterer treatment programs. So there's not very many experiments out there to see what actually works with these programs. So what we're going to do is we're going to take a look at programs that we're going to have programs with therapeutic approaches and non-therapeutic approaches. So we took 376 criminal court defendants who were accused of assaulting their intimate female partners. They were randomly assigned to two different things. One's a treatment group and one is a control group. Every time you have a treatment group, you have to also have a control group. It's just a thing. And you'll get more into that if you take the second stats class. We don't do much of that here in this class. That's the second stats class, 244. So the subjects entered into half of the subjects were in a 40-hour batterer treatment program. So they went through a therapeutic program where they learned it's kind of like anger management, but a little bit more in depth. Then the control group did 40 hours of community service. After 6 months, 21% of the males in the control group battered again. 10% of the males in the treatment group battered again. The results concluded that the treatment was effective in reducing repeat battering offenses. All right, so let's break it down in our steps. So the first step, identify the research objective. So our research objective was to determine whether or not batterer treatment programs worked. That was our program. That was our question. Probably this specific batterer treatment program. So that was our objective. So when we collected our information, we took a bunch of defendants and randomly put 40 of them into the batterer treatment program and 40 of them into community service. And then in 6 months, we looked at them and to see how many of them battered their intimate female partner again. This is just where we just collected our information. We didn't do, this is not even saying this is how many did. This was just collecting it. It's my collecting my data. Next. Organize and summarize the data. So we are not applying it to the population yet. All I'm doing is organizing it. After 6 months treatment, 21% in the control group battered again, 10% in the treatment group battered again. So all we're doing is stating, this is what happened. This is what we've observed. Number 4, this is the conclusion. This is our final thing. So we've extended the results of 376 males in the study to all males who batter their intimate female partners. So we are saying that those in the batterer treatment program are less likely to batter again. Yes, 3 is descriptive statistics. Yes, perfect. 3 is the descriptive statistics, and then this is the inference. This is applying it to the population. Good, thank you. So most of the time when you do a study like this and you come down to step 4 where we get our conclusion, we make our inference to the whole population. Most of the time, what we do is we have to do another study. We almost never do a study just once, because if you remember from your science classes, with the scientific method, your results have to be able to be replicated. We do the same thing in stats. Once you get your results, it has to be able to be replicated. So they would just go back to the beginning and they would get another big chunk of defendants and they would try it again and they would see if they get it replicated. It's the same thing as with the scientific method. We do it over and over and over again. All right. So that is our statistics method. This is how we do a study. I'm not going to, once again, I'm not going to ask you to go back and give this back to me and tell me about this again. This is just for your own information. And this is good information, especially if you're in any kind of psychology field. Any kind of psychology field, you're going to have to be able to run a good study. It happens a lot. Okay. Here's some more vocabulary. Jumping in on the vocabulary bandwagon once again. I'm hoping you all took my advice and are printing out the PowerPoints. I allow you to use notes on your tests as long as it's notes you've generated yourself. I consider notes you generated yourself as PowerPoints that you printed off and wrote on. Those would be notes you generated yourself. So you absolutely can print them off. I recommend 2 per page and then front and back. That gives you 4 slides per one piece of paper. You can print them at RCC for free. I believe it's still free at RCC. You can just go into the computer lab and print them off. And it usually gains most success for my students by doing that, print these off. So you've all heard variables before, and variables basically have the same meaning here as they do in your algebra classes. So it's the characteristics of an individual within a population. So basically variables vary. In algebra class, it's a different number, so it's still kind of a characteristic, but it's a number. Here, it could be a number if I'm asking the heights of people, or it could be words if I'm asking like the color of something. So variables vary. We're going to be doing lots of things with variables here. If all variables had the same value, we wouldn't need this class. So if everybody had the same height, all plants grew the same, all M&Ms were the same boring color, we would not need this class and it would be really boring. So variables vary. That's it. That's the vocabulary word. All right. Qualitative or categorical. You will need these right here. You will have questions on your homework and possibly on your test regarding these. So this is important information, highlighted or tab it or whatever. So qualitative or categorical variables, those 2 words are interchangeable. I usually say categorical because in my brain, categorical means categories and it's easier for me to remember, even though qualitative qualities, that makes sense too. So qualitative or categorical variables, they're based on some characteristic. They're usually words and not numbers. If they're numbers you don't do math with. So it could be gender, zip code, it could be area code in your phone number, hair color, birth date. If you're not doing math with the numbers, then it is categorical. Like your address, the house number, most of the time your house number is it's just categorical. It's just their characteristic. So any math you don't do, numbers you don't do math with, or words, that would be categorical or qualitative. Quantitative are your numbers. These are numerical measures. These are things that you might add or subtract or multiply or divide. You're going to do math with them and there'll be meaningful results. Could be temperature, how many days you studied, height, weight, how much money's in your pocket. That would be quantitative. Think quantitative, quantity. Quantitative are numbers that you couldn't do math with. Qualitative or categorical are words or numbers you won't do math with. Questions on those before we move on? All right. Okay, cool. So let's look at some examples. So researcher Elizabeth Kavavic and others, they studied things that affect the eating habits of adults in their mid-30s. So we're going to look at some different variables and determine whether they're qualitative or quantitative. So nationality. Nationality is just words. So these would be categorical, I guess I could say, or qualitative. It's not math, it's not numbers at all. It is a quality or a characteristic. Number of children, I can have two more children than somebody else, so this would be quantitative. It is a quantity, it will be quantitative. Household income, that's money. Money is numbers, so this is also quantitative. Level of education. Now, this is kind of a tricky one. So, level of education. Now, I have a bachelor's degree and I have a master's degree. So those are words. And I mean, I guess technically you can use first grade, second grade, third grade, or whatever to do math with those. But we don't generally do that. Those are numbers that we generally don't do math with. It's just kind of a characteristic. So I would call this categorical or qualitative. Daily intake of whole grains measured in grams per day. Definitely quantitative because it's numbers. You can do math with it. There we go. So I hope that cleared it all up. Hope that was helpful. These are the types of questions you'll get on your quiz and on your in your homework and your test. So you'll be able to kind of get an idea of what we're looking for. All right. Make sure you slow me down if I move too fast also, because I tend to do that sometimes. Sometimes I get excited. All right. Once again, you will need this for your homework, possibly for the test. So there's two types of quantitative variables. We're going to set qualitative aside for a moment. I'm going to put it in my pocket and I'll come back to it soon. We're going to set that aside and we're just going to look at quantitative variables. They come in two different types. We have discrete and we have continuous. So discrete variables have either a finite number of possible values or it's countable. So when I think of discrete variables, if I was going to graph them, I'm going to draw my beautiful, whoa, that's not what I wanted. Draw a little graph here. When I graph them, I have to lift up my pencil between each one because I can have two children. I'm not going to have 2.35 children. It's something that's countable. I'm going to go to the movie theater and buy two movie tickets. I can't buy 2.25 movie tickets. I just can't. So it's things that are countable, that can't take on every possible value. I had another example, but it left. Well, I mean, here we go. Example, number of students in class, how many TVs somebody sold last week, number of red marbles in a jar. These are all things that are countable. It can't take on every possible value in between. Okay, let me get rid of that too. Okay, so quality or continuous variables. If a continuous variable, if I graph it, it's going to be a line. I don't have to lift my pencil to graph it. They can have an infinite number of possible values. They're not countable. So it can take on every value in between two values. So thinking about height, I'm very short. I'm 5'2", but I had to be 5'1.5" before I could hit 5'2". I had to hit every value between my birth height and 5'2" in order to hit 5'2". I had to take on every value. Takes me 30 minutes to get to work. I have to drive for 28 minutes and 35 seconds before I could drive 29 minutes. It has to take on every value. Now, I know it's kind of weird because it technically can't take on any value, but generally when we're talking about income, we'll talk about it as continuous because, I mean, before you can earn $1,000, you had to earn $999.99. So technically we call it continuous, even though pennies are finite. It's just something that we do. It just is what it is. So examples here, heights of student in class, time it takes to get to school, distance traveled, weight of a baby at birth, things like that. Temperature is one of them because in order for it to hit 95 degrees, it had to be 94.3 degrees first. So it has to hit all of the other temperatures to get there. It doesn't just jump from 90 degrees to 95 degrees. Make sense? All right. And then move on. Okay, we're going to take a look at discrete rain amount. Rain is continuous, right? Because if I had 2 inches of rain one day, I had to have it 1.75 inches first. Right, great, good job. Okay, so we're back to Elizabeth Kavavic, and we're going to classify each of these as continuous or discrete. So I already did number of children. It is a finite number. It can't take on every number between. Therefore, we're at discrete. That's really ugly, R. Household income. I kind of already gave this one away. Household income is, we can consider it continuous. Yes, pennies are a thing, but you're not thinking about pennies. If you make, I don't know, $70,000 a year, it's just a number I grabbed. You're not thinking about the pennies, but you had to make every dollar and cent up into $70,000 in order to hit that. You had to hit them all. If I was going to draw a graph of how much money I was making a year, I'm not going to lift my pencil. Daily intake of whole grains measured in grams per day. Now, this one is a little bit tricky, but yeah, because you're not measuring each gram individually, you don't eat 1 gram at a time. I'm going to call this one continuous because I had to have 75 grams before I could have 100 grams. You have to eat all of them up to that number of grams. So it is, if I drew it, I always think of if I was graphing this, what would it look like? And this would be, I would not lift my pencil when I graph it. So that's kind of how I think of it. We understanding this one, are we good? Okay, good. Moving on here. All right. So I'm going to give you my, I believe this is the last piece of chapter 1. Yes, it is. Okay. This is the last piece of chapter 1, and this is the place where most people get caught up. This is something you're going to need to know. It absolutely is on the test. Think it's in the homework. I'm going to let you know how I remember each of them. And hopefully that will help you because for some reason this is kind of a sticking point for people. So I'm going to try to give you what helps me to remember each of these. So these are levels of measurement. So I'm going to try to hopefully help you out here. So the first level of measurement that we're looking at. So these two right here, just letting you know ahead of time, these two right here are categorical. Whoa, what happened? Stop that. These two right here are categorical. Categorical, man, I can't spell. Categorical. And then these two right here are quantitative. Okay, so I'm going to break it down that way first. What the heck with my colors? Okay, so first we're going to start at nominal. So nominal is categorical, as I said. So we don't need to name them, arrange them in a specific order. These are categorical, but they're not ordered. Like, for example, right-handedness does not come before left-handedness. It doesn't have to. If I'm listing them out, I don't need to list them in a specific order. Your religions, like thinking about you know, Latter-day Saints, Christian, Catholic, evangelical, Buddhist, I'm trying to think of all of the different whatever religions, beliefs, faiths. They don't have to be listed in a certain order. Same thing with color. They're not ordered. I'm just going to list the colors. They don't have to be in a certain order. So these are categorical, but order doesn't matter. And so that's what I'm going to write with how I remember it. Order doesn't matter. So if it's categorical and order doesn't matter, it is nominal. Okay, so let's look at ordinal. Now, it's right there in the name, ordinal, order. Order matters. So these are things where the order matters. It's still categorical, so it'll still be mostly words, or it'll be numbers that you don't do math with, but order matters. So it has all of the properties of the nominal level, but order matters, like grades, A, B, C, D, F. Order matters. You're not going to list it. If I listed on my syllabus the grades B, D, C, A, F, you would think I was crazy. I mean, now you're going to know I'm crazy because anyone who majors in math has to be crazy, but that would be a whole different level. I mean, you've seen the satisfaction ratings where it's like extremely dissatisfied way over here and then extremely satisfied all the way at the other end. So it's one extreme or the other, so that it's ordered a specific way: extremely dissatisfied, neutral, satisfied, extremely satisfied. It's listed in an order. Even like if you think about education level, you do kindergarten, first, second, third, fourth, fifth, and then hey, now I'm in middle school, sixth, seventh, and eighth. Now I'm in high school, and then I have associates, then I have master or bachelors, then masters. There's a way that we order them. So here, order matters. It's categorical, but order matters. Okay, to me, these two are the easy ones. The two quantitative ones are where it gets a little bit tricky, but I think y'all can handle it. So let's start with interval level of measurement. So the interval level of measurement, so this is quantitative. So these are going to be numbers. The important piece right here, a value of 0 doesn't mean absence of quantity. So if I say the answer to something is 0, it doesn't mean there's nothing there. It just has a value of 0. The other thing, the math that you can do with these numbers is addition and subtraction. I'll explain it in a second with some examples. So a value of 0 doesn't mean absence of quantity, and addition and subtraction. I usually just stick with, does 0 mean absence of quantity? That's my check right there. That is my main check right there. I'm going to highlight it because this is important. Okay. So temperature. Temperature of 0 doesn't mean that there's no temperature. That temperature doesn't exist. It just means it's really cold. It does not mean absence of quantity. There's still temperature because you can have negative numbers. Um, if I was going to do math with temperature, like say it's 90 degrees today, I think it's 91 or something, but I'm not going to say it was twice as hot during the day as it was at night. That just doesn't make sense. You would say it's 30 degrees hotter today than it was last week. You would use addition and subtraction. You would say and same thing, calendar years. Our calendar years did not start at 0. If I had a year 0, which we didn't start at 0, but if we had a year 0, it doesn't mean there's no time. It's just the middle of our calendar. And then we have our before Common Era, BC, BCE, whatever you want to call it, is lower than 0. Those are our negative numbers, even though we just call them BC. Same thing, elevation. You can have below sea level. It would be a negative elevation, but you can have below sea level. 0 does not mean absence of elevation. And I wouldn't say that mountain's 3 times higher than that mountain. No, I'd say that mountain's 2,000 feet higher than that mountain. Generally, it's addition and subtraction. So that's our interval level. I'm going to highlight that as well. That's the interval level of measurement. Also, I like playing with the highlighters. Okay. Ratio level. Whoa, I just dropped my pencil. Ratio level. So this is slightly different here. A value of 0 means absence of quantity. This is quantitative, but a value of 0 does mean absence of quantity. We would do multiplication and division here. So once again, I usually just check, does a value of 0 mean absence of quantity? Doesn't mean there's nothing there. Money in your pocket. If I have no money in my pocket, it means there's nothing there. If I have $0, there's nothing there. Somebody's income can be 3 times that of somebody else's income. I can multiply. You can say, I made half as much money this year as I did last year. That's division. I can do multiplication and division. It makes sense. Yes, you can also do addition and subtraction, but an absence of 0 does mean an absence of quantity. That's the most important piece here, that 0 means an absence of quantity. So height in feet and inches. If something is 0 feet tall, it doesn't exist. It doesn't exist. If it has no height, it doesn't exist. If something weighs nothing, it doesn't exist. If the time spent watching TV was 0, I didn't watch TV. And I can watch TV twice as long today as I did yesterday. That's the multiplication and division. Right. I'm going to say I'm 0, not, you don't have to write this. Absence. This is what I look for first, quantity. 0 is absence of quantity. Those are what I look for when I'm doing this. Any questions? I know this can be a little bit confusing. I know it's going to make like all the sense in the world right now, and then you go to do the homework and you be like, I'm lost. I'm going to do examples on the next page. Good question. On the next page right here. All right. So let's talk about which level of measurement these are. Okay, gender. So gender is qualitative or categorical. Therefore, it is either nominal or ordinal, depending on whether or not order matters. Think about it. Does order matter? With gender, order does not matter, so it's nominal. And I'm going to write the Y right after it. I'm going to write order doesn't matter. Okay. Temperature. Okay, temperature. So we need to think about this. Temperature is a number, and it is a number we would do math with. Therefore, we know it's categorical. So we know that it's one of these bottoms. It's either interval or ratio. Okay. Does 0 represent an absence of value? If I'm at 0, is that an absence of value? It's not. Therefore, this is interval. I don't have any good mnemonic device on this one about like with nominal and ordinal, there's no. So we're interval because 0 does not mean absence of value. Uh-oh. Okay. Number of days a college student studied this week. So this is a number that I can do math with. So it has to be either interval or ratio. It has to be one or the other. So does 0 mean an absence of value? It does. So if I don't study, if I have 0 days studying, I didn't study. There's no value there. So this would be ratio. 0 does mean absence of value. And I know that like by process of elimination, we know the last one, but I want to talk through it. Letter grade earned in stats class. So letter grades is that we obviously this is categorical because letter grades are letters. They're not numbers. You're not going to do math with it. Letter grades, there's a standard order to it. A, B, C, D, F. Order does matter. Therefore, this is ordinal. Order matters. Hopefully me walking through the thought process was helpful here. I hope so anyway. So those are the questions you ask yourself when you do these. First of all, figure out if it's a number that you can do math with, or if it's just a word, or if it's a categorical. So figure out that's going to break it into two pieces, like two of each one. Then if it is a number, ask yourself whether zero means an absence of value. That's the question you ask yourself. If it is categorical, ask yourself whether or not order matters. Questions? Okay, good. All right, we are on chapter 2. If you have all the information that you need to finish the chapter 1 homework, if you haven't done that already, I saw like 4 or 5 people already did that. If you haven't done the chapter 1 homework yet, you have all the information you need to do that. We're going to jump into chapter 2, just section 2.1. Jump into that right now. And this is just taking the categorical data and organizing it. So now we're going to take the quantitative data, the numbers. We're going to take the quantitative and put them in your pocket, pull out the qualitative and all the information you know about it. And that's what we're going to be working with for the next 20 slides. So we're halfway through our slides. Do you feel you need a break, or do you want to just push through and get this over with? It's really up to you because you're the only one here right now. You're all right? Okay. Let me know if you want me to pause it or whatever. I'm happy to do so. Perfect. This will probably move faster than the first stuff. Maybe, maybe not. I don't know. Okay. So I'm just reminding you, categorical data, it is categorized, it classifies an individual. It's usually a word, like a characteristic or a number you wouldn't do math with. So a frequency distribution, this is the new information. It's just we list the categorical data, and then we have basically like tick marks or counts of how many times it shows up or what the frequency is of each one. So whenever we say the word frequency, we've counted something. So if we say, the frequency, we have a frequency table of colors of Skittles that we pulled out of a bag, we're going to count how many yellow Skittles were they, and we're going to put them in a frequency table. I'll show you that. So frequency is the same as count. How many times did it show up? All right. So before we organize our data, when we collect it, originally when we first collect it, it is called raw data. Before I've done any cooking, before I have done any cooking of the data, it is raw. It's just a big pile of data, and I haven't done anything with it. Before I've organized it, it's raw. And we're going to be using raw data. I'm going to be asking you to give me raw data from time to time throughout. And I'm not asking for it to look all pretty and organized. You're just going to give me a list of all of the data, completely unorganized, and then you'll organize it later. We use tables, we use graphs, we use numerical summaries, we use many different things to organize it after we have our big pile of raw data. All right. Oh, look, we have a second person in here. Welcome. I see you. Welcome in. If you see two of me, it's because I always have my other screen up so I can see chat. Feel free to type in the chat if you have any questions. All right, moving on. We're on section 2.1 right now. I didn't know if you got there before we did that. So on the next page, you're going to see raw data of M&Ms that I pulled out of a bag. So I have a bag of plain M&Ms, and I just pulled it out of the bag, and it's going to be just raw data. Don't worry, you don't have to write it down or do anything with that. It's just a big pile of raw data. So as I pulled them out, I typed brown, brown, yellow, red, red, one at a time. I pull them out, and then I have this big pile of just crazy raw data here. I'm going to organize it nice and pretty in what's called a frequency table. You do not have to show the tally marks in your frequency table unless you want to. Nobody's going to get mad at you if you put tally marks there. So it's completely okay if you don't put them, and it's okay if you do. So what I did was I just counted them up. So I organized them into little piles because that's what I do. And I counted them up, and I've got my lovely tally marks. So I have the color and then how often it shows up. How frequently do I see that in my bag of M&Ms? So I had 12 brown, 10 yellow, etc., etc. So I just This is my frequency table. That's all it is. It's just adding up or saying how many times each one of these variables shows up. That's a frequency table. Not very exciting, but it is what it is. So relative frequency, now this is where the rubber meets the road. This is the important. Relative frequency is much more meaningful than just frequency. You've done relative frequency before, you just didn't call it that. So what relative frequency gives us is the proportion or percent each of our variables represents. So what percent of brown M&Ms do I have in the bag? What percent of blue M&Ms do I have in the bag? So you take the frequency, how many of that color you have, and then you divide it by the total number of items that you have, total number of individuals. So I would take how many blue M&Ms do I have, divide it by how many total M&Ms do I have. This is the relative frequency. So if a relative frequency distribution or a relative frequency table is the same thing as a frequency table, but instead of saying I have 5 of this color M&M, I'm going to say I have 12% of this M&M or 0.12 of this M&M. Let me show you what that looks like. So here we go. So I had 45 M&Ms total. So I took the 12 and I divided it by 45 and I got 0.2667. Now, if you're doing this for me, let's say you're doing this for me on a homework assignment or on a test, I don't care if you give it to me like this or give it to me as a percent. If you said 26.67%, I am absolutely okay with that. My Open Math, which is the program that's embedded in our Blackboard for homework, they will tell you what they want. They'll tell you if they want a decimal or if they want a percent. They'll tell you. So do what they say. So then for yellow, I took 10, divided it by 45. I took 9 divided by 45 for red, etc., etc. This gave me the relative frequency. What makes the relative frequency so important here is that it gives me, I just lost it. I can compare it to another bag of M&Ms because another bag of M&Ms that I dump out might not have 45. It might have 53. It could have 72. It'll have a different number of M&Ms in it. So if I say, oh, wait, you have 35 browns and I only have 12, man, I'm gypped. I'm comparing apples to oranges here because they probably have a bigger bag of M&Ms. But if I say I have 26.67% of brown M&Ms, and then they say, oh, well, I have 38% of brown M&Ms. Now I'm comparing apples to apples. I'm comparing similar things. I've kind of converted it to a common unit here. It's all percent. It's a relative frequency. So it's much more meaningful to have that relative frequency so I can see that I only have 6.67% of my bag is blue M&Ms. And I can see, am I being gypped or is that normal? Is that the way it's supposed to be? And you can see, oh, well, your bag has 7.2%. So yeah, we're probably okay. We have really close to the same number of blue M&Ms. Does that make sense? Any questions? We good? Okay. Oops. All right. So bar graphs. So when I make these lovely tables, we like to make a pretty bar graph. So we take for the bar graph, we're going to have, you can either make them horizontal or vertical. I like them vertical, but horizontal is pretty as well. I'm not going to discriminate horizontal or vertical, and I will grade you the same either way. So we label our category of data on one axis, and the frequency or the relative frequency will be on the other axis. Our rectangles are going to be equal width. They're not touching each other. The height of the rectangle will be the frequency or the relative frequency. And you're going to be in your homework for chapter 2, you're going to be analyzing a lot of bar graphs. They're going to give you a ton of them and you're going to be counting things like crazy. So we're going to construct two bar graphs for the M&Ms, do a frequency one and a relative frequency one. So here's my frequency table. We were already there. So here's my bar graph. So important things that your bar graph must have. And this, I want you to file this into your brain because when you're doing your lab on Thursday, you need to make sure that these things are accounted for. You need to have a title. You must have a title. Has to be. An overall title has to exist. You need to have axis labels. Axis labels. You need to have axis labels. So there we go. You have to have the axis labels. And then this will happen automatically. You're going to label the categories. This will happen automatically when you do your bar graph in Excel. It's going to happen automatically. So these are the things your bar graph needs to have. Your vertical axis is going to be either frequency or relative frequency. You're going to type those words in depending on which one it is. Your horizontal axis here is going to be whatever your variable is. It's just color here. And then your title tells you that it's colors of M&Ms. I'm not going to be super picky on how you label the horizontal axis or the title for the whole graph. I'll be pretty lenient here, but it needs to tell me what it is. I need to know what it is based on your titles. So this is the frequency one. So like taking a look at yellow, you can see that there's 10 yellow. I know you've seen 1,000 bar graphs, probably even this year, but this is a bar graph. So I'm going to show you the relative frequency bar graph. So here's my relative frequency table. Relative frequency bar graph looks almost identical to the frequency bar graph. Almost identical, except for over here, this right here is, oh, that was weird. Okay. That right there is your proportions instead of your count, instead of frequency. And of course, when you're labeling your vertical axis, it needs to say relative frequency if you're doing that type of table. Questions on either of these types of graphs before I move on?
Can you hear us?
I can hear you, yes.
Okay, before I rustle my hair further, my question was like, how do you label so it doesn't like not allow you? There were some issues. This is done on Excel, correct?
Yes, I will teach you step by step as if you've never been on Excel before in your life.
I've taken this class maybe one time or two times, and every time Excel would do things that I was not familiar with, and it would make my my graphs spin somewhere, and I was not even sure how I ended up with what. It should be simple, but in case.
Hopefully when I walk you through it, hopefully I can help you with that. So maybe collect your data ahead of time so that you can work through it while I'm doing it on Thursday. And then if something weird happens, you can share your screen with me.
It's more like labeling, and then it has a wrap around function that messes things up or just makes things go funky.
Okay.
Like remembering what I did, because if I'm going to repeat it, repeat I don't want to end up in the situation where I feel like I just toasted myself.
Okay. Hopefully when I'm actually in Excel, I can show you. It'll be much easier doing it that way. I'm actually showing you while I'm in Excel. So
Okay, no
fingers
worries.
crossed that I'll be able to help you there.
Yeah.
Okay. All right. So now this type of chart, Pareto chart, the only time I will ever mention it is this slide and the next slide. I will never again mention it because I'm required to teach you. It is part of the standards. I'm required to teach you, but you will not be assessed on it. There's no questions in the homework, but I'm just going to tell you what it is and we're going to move on and have a nice day. So a Pareto chart is just a bar graph, but instead it's kind of for aesthetics purposes, we label them in decreasing order. So the one that has the highest frequency goes on the far left, and then the one with the smallest frequency will be on the far right. So it's just kind of steps down. So I just reordered them so that my highest was all the way to the left and my lowest was all the way to the right. And I have no idea what happened to blue. I don't know where blue went. It disappeared. But regardless, blue should be down over here somewhere. I don't know. I don't know what happened to it, but let's pretend it's there. So Pareto just goes from the highest to the lowest, and it's just an aesthetics thing. It's just a preference. And I mean, there could be some reason you want to show it that way. We see graphs like this ordered this way a lot, like out in the wild when you see your stats out in the wild. We see them labeled this way a lot. So there you go. That's a Pareto chart. We never have to access it again. And look, we only have 6 slides left. We're so close to done. And it's only 6 o'clock. We've been here for just a little over an hour. We're getting
I have a question. Well, this will be re-available, right? Like I tried logging in, my computer like basically froze and gave me a death stare, and I was trying to get on like multiple times, and then it
Yeah,
just
I upload the recording to Blackboard.
okay.
Absolutely available. Yes. All right. So, um, just real quick, we're going to talk about comparing two data sets. You may do this in your final project, but don't even worry about your final project right now. Just don't even think about it. So sometimes we will have two different populations that we're looking at. Like for example, here we're looking at marital status of Americans. Are these Americans? They're Americans. Okay. So 1990 and 2006. Now here they're not super meaningful because our population sizes are different. So they're not super meaningful, but I can still compare them in a side by I can compare them in a side by side bar graph, but it is somewhat misleading. So generally, if we are comparing two populations, we will do relative frequency. So I would take each data value and I would divide it by the total number or how many times it showed up, the frequency, divide it by the total population size. So I'm not going to do that math because we already did that, but I'm going to show you what it's going to look like. So this is a relative frequency table. So we can see that in 1990, there were, it's like about 62% were married. And in 2006, we have about 58% married. And you can see never married, we're about 22% and about 25%. Putting it at relative frequency, as I said before, kind of brings it to the same unit. So we're comparing apples to apples. Because our population sizes were different, the numbers don't mean anything until we convert it to relative frequency. All right, questions here before I move on to pie charts.
You're comparing side by side numbers,
Yep.
okay?
All right.
And then you add them and divide them by either the male or female, and then you're
We
kind
do
of
the
or
relative frequency like we did with the M&Ms. Let me pop on back here to M&M. So I took the total number of brown and divided it by the population size. And then I do 10 divided by 45. So we're saying what proportion is that color. So here, going back here, instead of using our raw data here saying 40.4 million people were never married, I would take 40.4 million people and divide it by the total population at that time, and it gives me the proportion that were never married rather than the raw numbers. So
so would you take either dark blue or white blue, like or
I
to
do it
like
with all of we do it with all of them to give us our relative frequency.
but we would use both white blue and dark blue.
Yep.
Okay.
Yeah. All right, let's do pie charts. Okay, you've all seen pie charts, hundreds of thousands of pie charts your whole life. So we are not going to be doing them by hand. We will do them by Excel, but if we're doing it by hand, we would probably take a compass and we would use a protractor to determine the angle, and it would be all pretty. And there's so much fun to do by hand, but only for nerds like me. So I will never ask you to do it by hand, but it's really fun and I highly recommend it. So pie chart is a circle and it's a nice pretty way to show our categorical data. A lot of people would use pie charts more than anything else for categorical. They are kind of prettier than pie charts. So it's using each section of the pie chart is proportional to our frequency. So I like having the percents on pie charts because it's not as meaningful without the percents. So here's our, whoa, I took the 2006 data for the marital status, and I'm going to do a nice pie chart. You see this pie chart here? We have our key over here that shows whether they've been married or not, or widowed or divorced or whatever. And we have it's sectioned off. And I like having the percent so I can see 58% of people were married, 25% have been never married, and it shows our sections right there, and it has that key. When you're doing your lab, which we're going to talk about on Thursday, I'm going to ask for the percents on your pie chart because it's more meaningful that way. Without the percents, it's not super meaningful. And a lot of people will use that to try to be deceptive by not having percents on there. So this is our lovely pie chart. So this is the end of the material for 2.1. You have enough information to do your homework on that, but I'm going to talk about what you're going to need for your lab next class. I'm going to go to hopefully to a blank page. Will it let me? It's not going to let me go to a blank page. It usually does at this point. So I'm just going to find one that's almost blank and I'm going to write it down. Let's see if I can find one. Yeah. Ignore the Pareto chart on here. I'm just going to use this to write down. So for lab number 1, you're going to need 3 different types of data. So the assignment itself says you need 50 data values of each kind. You do not. You need 20 of each. And don't overthink this. The data does not have to be meaningful. Your variables don't have to be meaningful. The first thing that I want is I want 20 categorical. I want 20 categorical data values. So you're going to find a categorical variable and you're going to take 20 pieces of data. So an example, you could open your own bag of M&Ms and take M&Ms out of there and look at the colors. You can sit on your front porch and you can watch 20 cars go by and write down the colors of those cars. You can open up your closet and write down the colors or the type of the first 20 pieces of clothes. Shirt, skirt, pants, tie, belt, whatever. You can do that. You can look on your bookshelf and take 20 books and write down their genre. Anything. So 20 categorical. You can open up NFL.com and look at the main color in the logos of 20 different football teams. Whatever you want to do. I'm a football person, so I always go to football. So 20 categorical. Don't go crazy. And this is not the time to poll your friends unless you really want to. Polling your friends, the time to do that would be your final project. Some friends get really tired of getting polled a lot for these classes. This is not the time to poll your friends. Save that for your final project. Next, I need 20 continuous. 20 continuous. Some examples here. You can look at the length of the first 20 songs on your liked playlist in Spotify. What is the length of those songs? You can go on to look on the NBA website and look at the height of 20 basketball players. Hey, that's a cool one. I like that one. You can look at the last 20 days or pick 20 random days out of the year and look at the temperature, or maybe look at the average rainfall over the last 20 months. These are all different examples. You choose your own thing. Last, we need 20 discrete. Remember, discrete is something that is countable. Discrete is something that is countable. 20, you can look at, if you like vinyl like I do, can look at the number of songs on 20 records in your record collection. You can look at the chapters, how many chapters are in 20 of the books that are on your bookshelf. You can just pick 20 of your friends, how many kids they each have. You could, I don't know. Those are the things that I'm thinking of off the top of my head. So it the possibilities are endless. Don't do anything that's going to take way too much time. Just pick some simple things. Find some simple things. They don't have to be meaningful. I'm going to go through the lab on I'll go through the lab on Thursday. Thursday, we're going to finish up chapter 2. We're going to do section 3.1. and we're going to go over the lab. Those are what we're doing on Thursday. I am done with Tuesday. So any questions, things that you want recorded, because we are currently being recorded. So anything that you want to ask on the record for recording, I will turn the recording off in a second after we're done with that, and you can ask questions off the recording. So first, questions on the recording.
Where would we find our, okay, could we just take from anywhere? Would we have to credit our sources when we got it?
Not, well, you're gonna have to tell me where you found it, but like if it's a website, you'll say, hey, I got this off of NFL.com. If you asked your friends, you'll just say, I asked my friends on Facebook. You can say, sat on my front porch and looked at the cars. And if it was, I mean, you can give me the link to a website, or you can just type in, this is where I found it. I'm not looking for um, writing whatever, writing whatever the classes are called, writing 121 sources cited. You can just type out, hey, I went to, don't say Google, but you can say I went to NFL.com, or I went to Amazon and looked at the color of the first 20 things I saw, something like that. You don't have to be super specific. You have to tell me where you got it, but don't be super specific. You don't have to be super specific. Any other questions? That was a good one.
Just more and more, it's, material would also be found in the book,
What was
243.
what was that?
Would we have a book that we would follow, 243 statistics
Yes.
with the same?
Did you look at the syllabus? We looked at that?
I am getting around. It's very similar. I think I
Yes.
did take a class several
Yeah.
years ago.
So watch the
Yeah.
welcome video and take a look at the syllabus. That's all that
Okay.
in there.
Okay.
Okay. Anyone else while we're on the recording? Right. I'm going to turn the recording off.
Thank you very much. You have a wonderful night. Thank you.
Thank you. If I can find it. Okay.